Hi everyone, my name is Kostja from Gurobi Optimization, and thank you, Lindsay. Let's just take a closer look at our academic program today. Our product, the Gurobi Optimizer, is used by tens of thousands of academic users around the world. We tried to make it as easy as possible for everyone to retrieve and install free academic licenses directly from the Gurobi website. In most cases, you should be up and running within a few minutes, and I'll walk you through the process right now. Gurobi at its core is a high-performance, state-of-the-art solver for optimization models. The roots of these technologies are decades of academic research. And here at Gurobi, we strongly support the teaching and use of mathematical optimization within academic institutions. Academic users are first-class citizens. We provide the same full-featured, no-size limit versions of the product that our commercial customers use. So, are you entitled for a free academic license? Let's find out. In fact, the rules are quite simple. Free academic licenses are available to academic users for academic use. What does that mean? Academic users are faculty, staff, or students at a recognized degree-granting academic institutions. The nature of an academic use is the educational purpose. There are a few examples. The use of Gurobi in teach room, classroom, real or virtual, be it lectures, courses, or homework assignments, or the use of Gurobi for published academic research. It's perfectly fine to use Gurobi in your next paper. In fact, we're very interested, so make sure you drop us a note. Or the use of Gurobi to generate results for your thesis, bachelor, master, PhD, whatever. So within this scope, you can use the product free of charge with no limits. Keep in mind that you reach the boundaries of this license as soon as the results get used for any commercial purpose. We are also happy to help you with an academic consulting project with industry. You can contact us and we can discuss and check if your project is qualified. The same can be true for other research activities. Let us know what you plan to do and we'll see what we can do. You can just head over to our support portal at support.gurobi.com and ask our team. We're happy to help. You're also not alone with your questions around the product. Of course, individual product support beyond installation is reserved to our commercial customers. We can't help you with the homework. But there are tons of resources for you to look at. Gurobi moderates a huge community forum where you can ask all your questions around modeling, algorithms, programming, etc. You'll find the link to the community forum below this video, and you can also use it to search for interesting topics. You'll also find the Gurobi knowledge base on our website. With hundreds of articles, it's very likely that you can easily find answers to most frequently asked questions in no time. Again, head over to our support portal, pick a category, and look at all the articles that we have for a lot of very common questions. Your very first step towards an academic license is a registration on the Gurobi website as an academic user. So go to gurobi.com, pick register, and enter a little bit of personal information. All we need to know is you're an academic user, then you enter your personal information, your name, an email address, the name of your university, if you want also your academic position. We don't need a phone number, and of course, the country you're in. And then just click on Access Now. And within a few minutes, you should receive an email that allows you to set a password on the Gurobi website. Once you've set your personal password, you can immediately log into the Gurobi website. The My Account Overview page is the central place on the website to access your license information. You can always download the latest version of Gurobi from the website, even if you like before you have a license key. To do this, click on the download menu and select Gurobi Optimizer Download Software. Before you get to the download links, you need to read the End User License Agreement and accept it by clicking the button. Then you get to the page with the download links. You see multiple versions and multiple different platforms. Our general recommendation is always go with the latest available release and pick your preferred platform, Windows, Linux, or Mac OS. You can just go ahead, click the download link, and download the installation file to your local machine. Installing Gurobi is straightforward. Here is an example installation on a Windows system. You just open the installer, click Next. Again, you accept the license agreement. You pick an installation folder, and you should be good to go. Click Install to install the system, and then Gurobi will copy all the needed files over. If you need more help, you can always go to the documentation section and pick Quick Start Guides. The Quick Start Guides contain the documentation with installation help for all the available platforms. You can read it online or look at it offline. Now, let's take a look at the available license types. Individual named user licenses are, by far, our most used academic licenses. This license has a clear and simple scope: the unlimited use of the Gurobi optimizer by a single person on a single machine. People typically use this license on their home or work computer. Although one license is for one particular computer, there is in fact no limit on the number of licenses you can request. It is no problem at all to install as many named user licenses as you need on all your machines. Once installed, the license key is valid for up to 1 year. These licenses don't get extended. If they expire, you can simply request new ones and replace previously installed license keys. The license installation process is fully automated. Here's how it works. Now let's go back to the website to the My Account view. In the Academia menu, you can select Academic Program and Licenses. And in the description of the individual named user academic licenses, you will find a link to the free academic license page to request the free license. With a simple click, you get to the page that you can use to accept the conditions and to request your individual named user license with a click of a button. Now the process is finished and you can see your license immediately. You can see the license ID, the date, the purpose, the current version, and the expiration date. All that needs to be done now is the license key need to be installed on your local machine. The command to do is grb get key, and the command is printed on the website itself. You can just select it, copy it, and run it on your local computer. In this example, I'm on a Windows machine, and I just open a command prompt and I paste the command straight to the command window. Now what happens when this gets executed is that the tool contacts the Gurobi website, submits some information about the machines, and then the Gurobi license server issues the key for this particular machine. You can then pick a directory for the license key, and we recommend to stay with the default. Now the license was written to the license file, and Gurobi can be started immediately. This is the Gurobi interactive shell. You can use it to read in a model file and solve it right away. In fact, this is the Python API, and we see it works. The academic license is not limited to any API. You can use the shell, the command line, or any other API of your choice. Now, how does Gurobi recognize that you're an academic user? Quite simple. We maintain a worldwide list of recognized academic institutions and networks, and you need to connect through one of these networks when you use grb get key. Sometimes this requires the use of a VPN connection. If that doesn't help, feel free to contact our support team for further assistance. Named user licenses don't work in containers. Gurobi offers dedicated license types for container environments. This is called WLS, or Web License Service. This offering is also available for academic users. So let's take a look. You go back to the website to the My Account view. As an academic user, Gurobi allows you to create free WS academic licenses for 90 days that can be extended as long as you maintain your eligibilities. Make sure you don't share the access credential publicly, for example on GitHub. The license must not be shared with other users or stored in public repositories. Click on Review your Web License Service licenses. This will open the WLS Web License Manager. The process is very similar to named user licenses. There is some information about the license and some details, and you have to read the end user license agreement and accept it. And then again, with the click of a button, you create an academic license. In cases where you don't connect through a verified academic network, you might see an error message. Here's what should happen within a recognized academic network. Again, once you click the button, the connection is verified and the web license is created on our server. The created license is available immediately. So you can see here is a new license. It's temporary academic. It allows you to run 2 containers at a time. You can see the current expiration date, which should be 90 days from today. And you can always, again, extend this license when you connect through the academic network. You don't have to create container images yourself. Gurobi maintains a list of Docker container images directly on Docker Hub. Here's an overview. There are container images for the Gurobi optimizer, the Python API, but also for the compute server and the cluster manager, as well as a modeling example. If you click on one of these links, you go straight to Docker Hub, where you can find a lot more information about the image. If you scroll down the documentation, you will find information about the container structure, how you can link this to the web license service, and more technical information, for example, how you create the Docker file and how you mount the license file to the container. This is not the end. There are more licensing options that are not directly available on the website. Let's take a look. Site licenses are an alternative to individual named user licenses. Academic departments can request a free Gurobi license server within their network. This involves the installation of the Gurobi token server, so we reserve this option for system administrators only. Please ask your local network administrator to contact our support team, and we are happy to start the process. Another option is Gurobi Cloud. Gurobi has a platform as a service offering called Gurobi Instant Cloud. Our customers use this service to get access to exclusive cloud machines that run Gurobi Compute Server and are brought up on demand. This service is also available for academic users. The important part is the license is free, but the machine costs have to be covered by the end user. So if that sounds interesting to you, feel free to contact us and we'll show you a way how you can prepay for your machine costs and then use the Gurobi license for free for your academic purpose. Now let's take a look together at one of the modeling examples on our website. In fact, it's not really on our website, but it's hosted on Google Colab. So you can use a Jupyter notebook with a nice modeling example directly on that platform. The nice thing about this is you have a live environment in the backend and you can run it straight away without using your own machine. This modeling example is at the introductory level. We assume that you know Python, that you have some background with quantitative methods, but we will use a very simple optimization model to get you started. Once you click the link, you will go directly to Google Colab, where you can run the notebook, including the Python code, directly in that environment. Everything I'm going to say is also written in the notebook. The first part is really that the model gets introduced, that you see some basics, some links to the documentation, and you can also download this to your own machine. The model example is quite simple. Consider a consulting company with 3 open positions, 3 jobs, a tester, a Java development, and an architect. The company picks 3 candidates, 3 top candidates. We call them resources for the positions. And for the sake of simplicity, we call them Carlos, Joe, and Monica. So the consulting company had a competency test, and now there is a score. So there's an individual score to each resource, and the job is now quite simple. Find an assignment from resources to job with the best possible score. Of course, this is an optimization model, so let's use mathematical optimization to solve it. The first thing that you do in your Python modeling environment is usually you install the pip in license and the pip Gurobi Pi package. In order to do this, you can run this special command that is called %pip, and then you can install the module within the environment. It takes a little bit of time. What it does is it contacts the PyPy server, installs the wheel, and then the Gurobi API, the Gurobi Python API, is available within that environment. So the latest release is Gurobi 9.1.2. And the interesting piece of information here is that the package itself comes with a size-limited license. So there is no need to install a separate license. You can run it straight after installation. So now that the environment is set up, the first thing you do is you import the package. And one way to do it is you essentially import Gurobi Pi in your certain namespace, which is called GP here. So what we now have is we have a working Python environment in the background running in a container on the Google Colab platform. And then we can take a look at the model now and build it within Python step by step. The general problem type here is called the resource assignment problem. As said, we have some data. We have a list that contains the name of the three resources. We call it R for resources, Carlos, Joe, and Monica. And then we have a list J for jobs, which is tester, Java developer, and architect. So we use a mathematical language here, and we depict this as sets. So there is R in R and J for the set of resources and the set of jobs. So in Python, this is simply the definition of two lists, R and J. Now here's a diagram that shows the different scores. So what we can see here is Carlos has a score for 53% as a tester, while Carlos has a score of 27% as a Java developer and only 13% as an architect. Joe is really strong as a tester with 80%, etc., etc., etc. So the job is now pick a resource for each job. Each job needs to be covered, but of course, each resource cannot do more than one job. These combinations, including the scores, can be created in the Python API. And we use the multi-dict Python component here to create the data. So what we do here is we create a dictionary and an index set, and we say Carlos, as a tester, has a score of 53%. All right, now that the data is in place, let's start with the model. First command here is we create a model object within Gurobi. Once you do this, essentially you can also see that the license is available and it's part of the environment that is running in the backend. So we need decision variables. What are our decisions? The assignment of resource to job. So the variable essentially has two dimensions. One is the job and one is the resource. So we have a total of 9 variables here, and we can create these variables with a single lines by using the add vars command in the Python API. And what we do is this, we simply say create for each combination. Remember, the combinations is what we have defined here previously, and then create a variable for each combination and call it the assignment variable. So remember, now we have a model and we have the variables, and now we need to add the constraints. The first constraint is the job constraint. So what we want to express is that each job has to be covered. How can we do this within the model? Quite simple. The decision variables, which are binary variables, so 0 or 1, assigned or not assigned, we need to make sure that each job is covered. And so we do this by creating the sum over all the variables and enforcing that the sum is exactly 1. What does that mean? In any feasible model solution, exactly one resource needs to be picked for each job. So as an example for this first tester, tester is 1 here, we say, okay, x1 and 1, x2 and 1, and x3 to 1, the sum has to be 1. In fact, in Python, it's much easier to define this without naming the individual components, but in a general way. And here is a single line of code that does this. This piece of code loops over the set of jobs. So for all jobs in the job list, it creates a constraint. This is the constraint. And on the left-hand side, it sums all the decision variables for this job, and the whole sum needs to be 1. So this line creates all the job constraints we need. Next are resource constraints. Resource constraints are needed to make sure that resources are not assigned more than once to jobs. The difference with the job constraints is that it's not strictly equal to 1, but it has to be less than or equal to 1. So it's perfectly fine not to assign a resource, but you cannot assign a resource more than once. Very, very similar. What we do is we create the sum of all the assignments per resource, and we make sure that it's less than or equal to 1. Same structure. Loop over all the resources, create a constraint that says the sum over all the assignment variables for this resource needs to be less than or equal to 1. Now there's one missing piece. We now have the variables, we have the constraints, but we also need an objective since we're optimizing. And the objective in this case is the sum of the scores. So all we have to do is we have to multiply the variable with the score. Remember, it's a binary variable, so when we multiply the score with the variable, it gets multiplied with 1, which means the score itself, or I get multiplied with 0 if the variable is 0, and that means there's nothing. So the sum of the product between the scores and the variables gives us the total scores of all the assignments in any feasible solutions. How do we do this? We sum all the scores together, and then we say, okay, maximize the score over all the jobs and all resources of the product of the score with the variables. Again, this is very, very simple in the Python API with a single line of code. What it does here is it says, set the objective function of the model and create the product, the dot product, of the set of decision variables with the scores. So this essentially creates the multiplication or the matrix multiplications between all the assignment variables and their respective scores. Simple as that. And then the model is done. Now, how nice is that? We can, if we want to, write the model out as an LP file so that we can essentially read it. And here is an example. So this is a human readable version of the model. It's essentially a printout of what we've just defined with the specific values that we've used. We see here at the top, we see the objective function, the maximization function, so all the assignment variables with their scores. And then we see the job and the resource constraints. Again, job constraints needs to be the sums of all assignments over a particular job needs to be 1. And for the resource constraints, the sum of all the assignments per resource needs to be less than or equal to 1. And now we're done. That's it. We've defined the full optimization model, and we can ask Gurobi to solve it. So all we need to do is this, we need to call the optimize message on the model. And once we do this, you can see this is a simple model, so it's essentially solved in the fraction of a second. And here is the result. So it's solved in 5 iterations, and the optimal objective is 193. So how do we see the details? Again, we do this with a Python API, and we iterate over the variables. And if the variable has a non-zero value, for numerical reasons, we don't check exactly for 0, but anything that is larger than 10 to the minus 6, we print the variable and the value. And if we execute this piece of code, what we get is we get 3 assignments. Carlos is assigned as a tester, Joe is assigned as an architect, and Monica is assigned as a Java developer. And the sum over all these scores is 193. So the nice thing about optimization is we now have a guaranteed optimal result. There is no other solution to this optimization model with a better total score. So we've optimized the job. But this is not the end. We can extend the model. Here is an example how we can add budget constraints to this resource assignment problem. So for example, if the assignment has a cost value and we have a budget, it means that the total assignments must stay within a certain budget. And we can easily extend the notebook to cover this aspect. So let's go back. Again, we have the resources and the jobs, we have the scores, but we also have a new value, which is the cost. And you can see this is now added to the way we create the data components. We create the combinations, the scores, and the costs in the same command. Again, we use the multi-dictionary data structure. You can look at the documentation to find out more. But what we essentially do is we create the index set and we create the data for each index element in the same run. So the costs are now here. Carlos as a tester costs 1, Joe as a tester costs 2, and Monica as an architect costs 3. And then we also have a budget, and the total budget is 5. So how do we put all of this in a model? Quite simple. First, we define the data, then we create a new model, we create the decision variables exactly the same way as we did before, but then we also have a new variable that is called the gap. And once we've done this, we add the job constraints, we add the resource constraints, and now we add a new budget constraints. What the budget constraint essentially says is that the sum over all assignments and the product of each assignment variables with the costs, so the total costs over all assignment, needs to be within the budget, so it's less than or equal to the budget value. So what's now the objective function? Well, the objective function is similar to the first model, but we change something and we add the gap. So the objective function is now to maximize the total matching score of the assignment minus the penalty associated of having gap values with a variable equal to 1. So we add a penalty for not filling a job position. In this case, it's 101. So here's the command that sets the objective, and this is exactly the same thing as here. Set the objective as the product of the scores and the variables, just like we did before, minus the penalty times the sum of all the get values. And of course, this needs to be maximized. So again, we execute, and we optimize. So here's the result. What do we see? It takes a little longer, still fractions of a second, but a little longer, and the result is different to the previous run. So we see that an optimal solution was found with an objective function value of 52. So what are the results? Let's use the same way, loop over our combinations, print the name, print the value, and compute the score. So we can now see that we don't have 3 assignments anymore. We have 2. One is the assignment of Joe as a tester, and then we have the assignment of Monica as a Java developer. The role of the architect is not assigned at all. The total matching score is 153, but we now have the budget, and the total costs with allocating the 3 resources would be 6,000. The budget is only 5, so the optimization model took care of these new budget constraints. So what we had to do is we had 2 resources to fill the job demand, and 1 job is unfilled. So that maximizes the total matching score. Great, isn't it? So this is a simple example of a simple model, and you may need some time to walk through it, find your way, understand the details, and once you master this first notebook, everything's, the future is bright. You will find a lot more interesting examples on our website, on Google Colab, and you can use these examples to learn more and more about modeling. And then I'm sure one day you will find a use case in your job or wherever you are, and then you can start to build your own optimization models for your particular use case. So thank you for your time. Head over to Gurobi website, look for the Jupyter modeling examples, and then you'll find the links to the Google Colab place. And that's it for today. We hope that it was helpful to learn more about our academic program, the licenses, the resources. See you next time. Goodbye.